Hello, you're welcome back. All right, so we are going to be looking at problems and solution. Okay, we've already discussed different types of semiconductor. We've talked about the formula for their conductivity. Okay, so we are going to apply all the formula that we've learned so far to solve a typical examination question. All right, so now I'm gonna start with your question. Okay, I'll just dictate the question, write the parameters, then I'll solve. Now this question goes like this: calculate the intrinsic conductivity of a silicon. So the question is calculate the conductivity of a silicon. That is the question mark. All right, at room temperature, if n, if n, that is the charge carrier density, okay, is equal to 1.14 times 10 raised to the power of 6. 1.14 times n raised 10 raised to the power 6, okay, per meters cube. Per meters cube. Then we are also given that the mobility of the electron UE is equal to 0.145. 0.145. Then we are also given that UH, the mobility of the hole, is equal to 0.05. All right, and you know that the charge of an electron is 1.6 times 10 raised to the power of minus 19 coulombs. Okay, so we are looking for the mobility of silicon, which is an intrinsic semiconductor. Of course, I've given you the formula, right? So the mobility of silicon is given by the NIE bracket open UE plus UH. UE plus UH. Okay, so with what I have, I can now evaluate my uh, my conductivity. So let's actually do this. So this is going to be equal to N is a 1.14, 1.14, then times 10 raised to the power of 6 multiplied by the charge of one electron is 1.6 times 10 raised to the power of minus 19. Okay, then bracket open, U is 0.145 plus UH 0.05. Okay, so let's work on this. I think definitely we need a calculator. So I got a calculator. I'll get a calculator. Okay, here we go. So calculator, let me work on the bracket first. 0.145, then plus 0.05. All right, then I have to multiply that result by, I have to multiply that result by 1.6 and 1.14 times 1.6 times 1.14. What do I have? Okay, so that is going to give me 0.336 approximately. 0.36. All right, then let's work on the powers of 10. Now, please, this is 16. Okay, this the n is 1.14 times 10 raised to the power 16. So please just effect that correction. So let's work on this. 16 minus 19, that should be minus 3. Okay, so you can still decide to put it in standard form. If you put it in standard form, that's going to be 3.6, then times 10 raised to the power minus 4. All right, and of course, it's conductivity. Conductivity is measured in ohm. Okay, per ohm per meter. Per ohm per meter. As simple as that. All right, so this is number one question, one application. Now let's look at another application. All right, here the question actually goes this way. Calculate the donor concentration, okay? So remember donor concentration, ND, question mark, that's what we're looking for. In N-type semiconductor, okay, N-type semiconductor having a resistivity. So the semiconductor has a resistivity of 100 ohm meter. 100 ohm meter. All right. So, of course, we know very well that the electronic charge is going to be equal to 1.6 times 10 raised to the power of minus 19. That's another question, okay? We're asked to derive the formula that we use. That derivation is what I didn't do, okay? If I have the time, I will derive how we got the formula for all this formula, okay, for the conductivity of an increasing semiconductor and that of an extrinsic. But I'm much interested in actually in applying this formula, right? So in this case now, remember we are actually we are dealing with n-type semiconductor, all right, and we are looking for the donor concentration. Remember the formula: conductivity of the n-type semiconductor is equal to the donor concentration multiplied by electron charge, then multiplied by mobility of the electron. But it happened that for me to be able to get this donor concentration, I need to get the conductivity. Where do I have to? Where am I getting conductivity from? From resistivity. Okay, I already told you that conductivity is the reciprocal of resistivity. Okay, conductivity of a material is reciprocal 1 all over its resistivity. So we're looking at 1 all over the resistivity. That's 1 all over 100. Okay. So if I do 1 over 100, I'm going to have 0.01 if I'm not mistaken. Okay, yes, I'm not mistaken. Okay, per ohm per meter. Per ohm per meter. All right, so let's now get what we're looking for. So making donor concentration the subject of this formula, I can simply say that donor concentration is going to be equal to the conductivity divided by charge of an electron, then multiplied by the mobility of the electron. So let's work on this. Conductivity 0.01 all over the charge of an electron, that is 1.6 times 10 raised to the power of minus 19, then times mobility of the electron. Okay, which of course was given us, did I write that mobility of the electron here? Okay, the mobility of the electron is of the electron here was given as 0.36. Okay, was given as 0.36. So let's put that down. 0.36. Okay, so with what I have now, I can finalize my solution. So what I'm going to do is 0.01 divided by 1.6 times 0.36. Let's do that. 0.01 divided by bracket open 1.6 times 0.36 bracket close. Okay, equal to, that is 0.01, 0.02 approximately. Okay, 0.02. Don't forget, I still have 1 divided by 10 raised to the power minus 19, which is a reciprocal. Okay, so you know how we do reciprocal. So the 10 raised to the power minus 19 actually will be inverted to become 10 raised to the power 19. Okay, so I can I can put this in standard form. If I put it in standard form, I move the decimal place 2 times, okay, to this point. That's going to be 2.0. 2.0, okay. Then of course, if that happens, the power of 10 will reduce by 2. So that's going to be 2.0 times 10 raised to the power 17. Okay, per meters cube. That's just a unit of concentration of charge carriers. All right, so. More question. Let me clean up. Let me clear up my screen so that I'll be able to have space. Okay, that's another question I have here on this. I'm looking at it goes this way. An N-type silicon has a resistivity of 1500 ohm meter at certain temperature. Compute the electron hole concentration given that Ni. Okay, let me read it again. An N-type silicon has resistivity. So you know I have to write parameters. Resistivity according to them is 1500. Okay, per ohm meter, right? At a certain temperature, compute the electron hole concentration. So we are asked to compute both the electron and the hole concentration. So we are looking for the N electron concentration of the N-type semiconductor question mark. And at the same time, we are also looking at the whole concentration of the same N-type semiconductor question mark. Okay, so these are the two things that we are looking for. But we are given that the electron concentration of the intrinsic semiconductor, okay, according to the question we have been given this, the intrinsic semiconductor concentration, all right, is 1.5 times 10 raised to the power of 16. All right, then what again are we given? We are also given the mobility of the electron to be equal to 0.14, and we are given the mobility of the hole to be equal to 0.05. Okay, so how do we flow? Okay, so the very first thing, and let me start with, if I want to get, I can get the concentration of the electron, okay, of the entire semiconductor, if you can still remember the formula, right? If you can still remember the formula, the concentration, the conductivity of n-type intrinsic semiconductor is given as the electron concentration multiplied by the electronic charge, then multiplied by UE. Okay, so we have all these parameters, so it is easy enough for me to get this. Okay, so that's going to be equal to conductivity, then divided by electronic charge, then multiplied by mobility of the electron. Okay, but first, I don't have my conductivity. I need to find out my conductivity from resistivity. Okay, so I can just, of course, conductivity is reciprocal of resistivity. That's 1 over 1500. Let me do that. Okay, 1 divided by 1500. Okay, I think I should just put that. Let me put that there. 1 over 1500. So that I can simplify everything at once. Okay, and then of course divided by this division sign. I'll change this division sign to multiplication sign. Then I'll have to invert the divisor. I have to invert the electronic charge. It comes to the numerator, all right? Times 10 raised to the power of minus 19. Okay, then of course multiply by the mobility of the electron, which we have to be 0.14. Okay, so let's get this over with. So I'm having 1.4 times 0.14 divided by 1500. Okay, 1.6 times 0.14. Okay, am I making a mistake? Yeah, it's like I am making mistake. Am I really making mistake? Okay, yeah, it's better. Let me not. Let me okay. Let me calculate this as it is here. Okay, let me just calculate it as it is by cross multiplying to make my solution easier. Conductivity is 1 over 500. I'm looking for the concentration of the electron, then times electronic charge, which of course is what do I have? Times 1.5, 1.6 times 10 raised to the power of minus 19. Then multiply by the mobility, which of course is 0.14. So I had to cross multiply now. So if I cross multiply to make the concentration, electron concentration, the subject of formula, what I'm gonna be having is, right, the whole of this all over 1, right? So what I'm going to be having is 1 all over 1,500 times 1.6 times 10 raised to the power of minus 19. Okay. Then of course times 0.14. All right, so let's finish up. So electron concentration is going to be equal to, all right, 1,500, 1 divided by 1,500 times 0.14 times 1.6. Let's do that. Okay, 1 divided by, bracket open, 1,500 times 1.6 times 0.14. Okay, so close bracket. Then, so I have 0.003 approximately. 0.0, how many zeros? Okay, 003. Then not forget reciprocal of 10 raised power minus 19, okay? That's going to be 10 raised power plus 19, 10 raised power 19. Okay, so of course in standard form, 1, 2, 3, I move it backward 3 times. So my concentration is going to be 3.0, then times 10 raised to the power of, I have to subtract 3 from this, and that should give me 16, right? 16 per meters cube. All right, and remember that is the concentration of the electron. What of the hole? How do I now get the concentration of hole? Remember the formula for the conductivity of entire semiconductor doesn't make provision for the concentration of a hole. It's only for electron. Why? Because hole are minority carriers. Remember that, okay? So that is why this formula only actually enable me to find the concentration of the electron. But how do we now get the concentration of the hole, the minority carriers? Remember the law of mass action. That's where we apply it, okay? The law of mass action, Ni square, okay, is equal to NNPN. Okay, if you can't remember, you just go back to that video. You remember when I give you this formula, the law of mass action. Okay, so with this law of mass action, it is easy for me to get my whole concentration, which of course is going to be equal to Ni square that I already have. Okay, then of course divided by Nn that I've already calculated. Okay, so Ni is 1.4 times 10 to the power 16. So I'm gonna have 1.5, okay, times 10 raised to the power of 16. Remember, it is being squared. So I gotta square it, then divide it by 3.0, then times 10 raised to the power of 16. Okay, so of course, I would do 1.5 square, then of course 10 raised to the power 16 square. That will give me 10 raised to the power of 32. Okay, 1.5 square, what do I have? 1.5 square, okay, then divided by 3, what do I have? 0.75. So I'm having 0.75 for just the numbers, okay? As for the powers of 10, if I square 10 raised to the power 16, I'm going to have 10 raised to the power 32, okay? Remember, by division law of indices, okay? That's going to be 10 raised to the power 32 minus 16, which of course is the power of this of the 10 in the denominator. So let's actually flow with this. 32 minus 60 is 16, right? So I'm having 0.75 times 10 raised to the power 16. Okay. You can still decide to put your answer in a standard form by making it 7.5. Just one decimal place backward. Then this now, powers of 10 now becomes 15, all right? 10 raised to the power 15, then meters cube. As simple as that. Okay, so this is the simple application of what we've learned so far on intrinsic and extrinsic semiconductor. Okay, so we still solve more questions. All right, and as we progress, see you in the next video. Thank you very much.